Hello class, this is Econ 510 Managerial Economics class. Today is January 18th, 2022, Tuesday. The class will discuss the supply side of the market, and we combine the demand and supply side together at the end of the class. And then we are going to analyze the market. So remember that last time we covered the demand side in detail. And today we start with the component of supply and the market structure. So let's watch the video clip.
In the last lectures, we've been considering the consumer side of the economy, those factors that influence the demand for particular goods and services. Now we'll shift our attention to the supply side of the economy. We'll look at the determinants of the supply of a particular good or service. Let's think now about the agents we're studying, people who offer bread for sale. These are people like bakers and other stores that are trying to make a profit by selling bread. Profit is the difference between the revenue that a company earns and its costs of providing its good or service. So any factors that influence profit, that is, any factors that influence revenue or costs, are going to have an effect on the supply decisions of firms. Let's look then at some of those factors, because they turn out to be the determinants of supply. Think about the market for bread. What are the determinants then of the profitability of a company that might want to sell bread? What are the factors that are going to influence how much bread they are profitably able to offer for sale? Well, one important component of their decision will be the price at which they can offer bread for sale. If the price of bread is high, the prospects for profits are good, and it's more likely that there will be lots of companies offering lots of bread for sale. If prices of bread are low, on the other hand, it's unlikely that a lot of bakers will be able to make a profit, and the quantity of bread offered for sale will be lower. Well, that works on the revenue side of things. What about on the cost side of things? One important factor will be the cost of inputs, like bread, or like milk and eggs, things that are used to make bread. So the input prices are important. The higher the input prices, the higher the company's costs, and the less profitable it will be for companies to offer bread for sale. When input prices are lower, it's going to be more likely that a company can make a profit selling bread, and the amount of bread offered for sale is likely to be higher. However, input prices are just one part of the cost side of a firm. Another side of this equation is going to be technology. How is this firm going to be able to combine inputs to produce bread? If you have good technology, you can get by with very little milk and eggs to make your bread. If you have bad technology or are wasteful or unproductive, you're going to have to buy a lot more inputs, and that raises your costs of production. So technology is important. The better technology is for producing bread, the lower the costs of the company, and the more likely it is that that company will offer lots of bread for sale. If technology is not as good, costs will be higher, and the bread supplied will probably be a smaller quantity. One more thing that influences the supply decision will be expectations. Just like in the case of households, producers are looking forward to the future, trying to figure out whether the prices of bread will go up or down, what will happen to the prices of their inputs. And as they change their expectations, they may be changing the timing of production. If they think bread prices are going to rise next week, they may save bread on their shelves this week and try to sell it later. They may freeze bread in anticipation of being able to charge a higher price in the future. So we have then four factors that influence the supply decision of firms: the price of bread, the price of inputs, technology for production, and expectations of future prices. Now, of course, I'm going to want to turn these into a supply function. So I need mathematical symbols for all of these ideas. we'll let the quantity of bread supplied be represented by Q sub S. And I'm using the color blue here because blue will be my official color for supply. The price of bread will represent, as before, with a P. The price of inputs with P sub I. The technology of the firm will represent with the letter T, and the expectations of future prices with the letter EX. Now, we're ready to write down a supply function. A supply function shows the amount of bread that a firm is willing and able to supply profitably as a function of all of the variables that influence its decision: the price of bread, the price of milk and eggs, the technology of production, and the expectation of future prices. So let me take my icons off the pad, and I'll turn these symbols into a function. We want to now describe the quantity of bread supplied as a function, and I'm going to use for my function the letter S, my blue S, to be supply. So I'm going to have a function called a supply function, and the quantity of bread supplied depends on all of these variables: the price that we can charge for a loaf of bread, the price that we have to pay for milk and eggs and other inputs, the technology, that is, how effectively we can turn inputs into output, and finally, the expectation of future prices. There you have it, the supply function for a particular firm. If you know the value of prices, input prices, the state of technology, and the expectations for the future, you'll be able to say how much bread a particular firm will offer for sale. And there you have it, the quantity of bread supplied expressed as a function of all of the variables that influence the supplier's behavior. Now what we'll do is look at a supply schedule, the behavior of a particular firm in response to different possible prices for a loaf of bread. Then we'll take the supply schedule and turn it into a supply curve. In the last lecture, we made a list of those factors that influence the behavior of suppliers. In this lecture, we're going to look at a particular factor, that is, the price of bread, and how the behavior of suppliers is related to the price that they can charge for the product. Remember that we said that the quantity of bread that was supplied was influenced by the price of bread, the technology of production, the price of inputs, and the producer's expectations about future prices. What we'll do now is look at the relationship between the quantity of bread supplied and the price of bread, holding constant all of these other factors. Once again, we'll be invoking the assumption ceteris paribus to look at how the quantity of bread supplied in the market is influenced by changes in the market price of bread, holding constant expectations, technology, and the price of inputs. This will give us a supply schedule, and we'll begin by looking at the supply schedule for an individual firm. Suppose we have a baker whose behavior can be summarized in this table. That is, the quantity of bread that our baker supplies is related to the price of bread. When I draw this supply schedule, I am invoking ceteris paribus. I'm holding constant everything else that this baker cares about: technology, input prices, expectations about the future. I'm looking only at how his behavior would change in response to a change in the market price of bread. So, for instance, our particular baker here will supply one loaf of bread per week. That is, he is willing and able to offer one loaf of bread for sale each week when the price of bread is 40 cents per loaf. If the price of bread goes up to 60 cents per loaf, he is willing and able to offer 2 loaves of bread for sale a week, and so forth. At a price of $1, the quantity supplied is 3 loaves of bread. At a price of $1.50, the quantity supplied is 4 loaves, and so forth, all the way to the end of our chart. Again, this supply schedule represents a relationship between the market price of bread and the quantity of bread that our seller is willing and able to offer, holding constant all of the other factors that influence the supplier's behavior. The next step in this analysis is to take the information from this supply schedule and convert it into a supply curve. That is a graph that represents the relationship between price and quantity supplied for our particular baker. So that's where we'll go next. I'll move this information over onto the board, and I'll put up axes here that I can use to graph the relationship between price and quantity for this baker. So on the horizontal axis, we will be measuring the quantity of bread that is supplied, that is how much bread our seller is willing and able to offer for sale. And on the vertical axis, we will represent the price of bread, which again will be measured in dollars. Now, I'm going to take the information from the table and represent it in the graph. So at a price of 40 cents per loaf, we get a quantity of bread supplied of 1 loaf per week. So here's a blue dot that represents that combination, 40 cents from the vertical axis and 1 loaf of bread from the horizontal axis. We get 2 loaves of bread when the price goes up to 60 cents per week. So let me go on into my diagram. 2 loaves of bread at a price of 60 cents gives me a point like this one. I get 3 loaves when the price is up to $1. And this particular baker will offer 4 loaves for sale if the price of bread rises to $1.50. We get another loaf of bread at a price of $2.10 per week. So let me put that point on the diagram. And we get 6 loaves of bread when the price is all the way up to $2.50 per week. In each case, I'm measuring price on the vertical axis and quantity on the horizontal axis. I get 7 loaves of bread at a price of $3 per week, or $3 per loaf, 7 loaves of bread per week. At a price of $4 per loaf, this particular baker is willing to offer 8 loaves of bread for sale each week. So that gives me this point. And at a price of $5, this baker offers 9 loaves of bread for sale each week. So that gives me this point. Now, are these the only imaginable quantities of bread? No, you can imagine fractional quantities. The baker could offer 2 loaves for sale over the course of 3 weeks, which would average out to be 2/3 of a loaf a week. Or he could offer 3 loaves for sale every 2 weeks, which would average out to be 1.5 loaves per week. So it's possible that there would be fractional loaves of bread sold. He could even bake a half a loaf if he was so inclined. And it's also possible to imagine prices varying continually from 0 all the way up to $6, $7, $10. So the continuous variation of prices and the continuous divisibility of quantities of bread allows us to connect these dots and make a smooth supply curve representing this baker's behavior. So let me connect the dots. And when I connect the dots, I have created a supply curve. The supply curve is a collection of points representing the quantity of bread that a baker is willing and able to offer for sale in a given period of time as a function of the price of bread per loaf. So it's a relationship between price and quantity supplied for this particular baker. I'm going to label this curve with an S to indicate that it's the supply curve. Now, there is something you need to notice immediately about the supply curve, and that is that the supply curve slopes upwards. This is a representation of what economists call the law of supply. The law of supply is a regularity that we notice in the economy. That is, as the price of a good or service increases, the quantity that is offered for sale generally increases. Now, does this make sense? What's the intuition behind the law of supply? The intuition behind the law of supply is a concept that we've already considered in this series, and that's the concept of increasing opportunity cost. That is, the more bread a particular baker offers for sale, the higher the cost of each additional loaf. The cost of each additional loaf tends to rise. Here's an example that might make that clearer. Think about what the baker puts into this operation. Every time this baker bakes a loaf of bread, that's taking extra time and extra resources. To bake one loaf of bread might take time away from watching television, time that's not especially valuable. His opportunity cost for that hour is small. But if he spends more and more time in the kitchen baking bread, eventually he's taking time away from fishing. He's taking time away from spending with his family. He's taking time away from pleasurable leisure activities like reading. He may also be taking time away from other opportunities to make money. And the more bread that he produces, the more he is having to go to hours of time that are more and more valuable to him. Giving up his TV time is no big deal. Giving up his fishing time is a little more serious. Giving up his family time is more serious still. So we have to pay him larger and larger amounts of money to get him to produce larger and larger quantities of bread. Getting him to produce a small quantity of bread doesn't take much of his time, so he's willing to do that for a small amount of money. But getting him to produce a large quantity of bread begins to take away from time that's more valuable. His opportunity cost of producing additional loaves of bread continually rises as we eat into more and more valuable time, as we take him away from more and more pleasurable activities. That's why it takes higher and higher prices to get this baker to make more and more bread. The supply curve is upward sloping because of increasing opportunity costs. We'll see later in this series how the upward sloping supply curve is related to increasing marginal costs associated with diminishing productivity of resources. But for now, a good answer to the question, why does the supply curve slope upwards, is this. The supply curve slopes upwards because the opportunity costs of production rise as the baker makes more and more bread. In the next lesson, we'll look at those factors that shift the supply curve. That is, what if we allow those things to vary that we previously held constant? What if we relax the assumption of ceteris paribus and allow the price of inputs to change or technology to improve? How would that influence the relationship between the price of bread and the quantity that our baker is willing and able to offer for sale? The supply curve shows the relationship between the price of bread and the quantity of bread that a seller is willing and able to offer for sale, holding constant other factors that influence supply, such as the price of inputs, technology, and expectations about future prices. What happens to the supply curve if we change some of those other variables? Of course, the supply curve shifts. In this lesson, we'll be looking at a particular case of a shift in the supply curve. Then, in the next lesson, we'll be looking at a catalog of all of the factors that can shift the supply curve. So let's start with a specific example. Remember, we're talking about a particular baker who has this relationship between price and quantity. This is the supply schedule that we used in the last lesson. Suppose now that we allow a change in one of the factors that we held constant when we wrote down this schedule. Suppose, in particular, that we allow the price of inputs to increase. An increase in the price of milk and eggs and other inputs used to produce bread is going to influence the profitability of this bakery. In particular, with higher input prices, it's going to be less profitable to make bread, and the response of the baker will be to scale back his operation. With the higher prices for inputs, we will see a smaller quantity of bread supplied at every price. So we can put these numbers in the table to represent the quantity supplied after the change in input prices. And as before, I'm putting a little apostrophe after the S, a symbol we usually call prime, to indicate S prime is a new supply schedule after the change in input prices. So with the higher prices of inputs, this baker is unwilling to offer any bread for sale at a price of 40 cents per loaf. We get the first loaf of bread on sale at a price of 60 cents per loaf. 2 loaves offered at $1 per loaf 3 loaves at $1.50 per loaf, 3.5 loaves per week sold at a price of $2.10 per loaf, and so forth. Notice that we have a smaller quantity supplied than before at every price. A change in one of the variables that we previously held constant required us to redraw the entire supply schedule. Now, I'll move this information over to the board and will represent this change in supply as a shift in the supply curve that we drew. Here I go, moving the information to the board. And I will go back to the diagram that we were looking at before. With a change in input prices, with an increase in the price of milk and eggs and other factors that go into producing bread, we're going to get a change in the supplier's behavior. Let me simply graph the numbers from the table over on the board. At a price of 40 cents now, we have 0 loaves of bread offered for sale. So the new dot for the new supply curve will be over at a quantity of 0 at a price of 40 cents. So it shifts over to the axis itself. At a price of 60 cents per loaf, we now get 1 loaf of bread offered for sale per week. So here's a point on the new supply curve at 60 cents per loaf and 1 loaf per week. At a price of $1 per loaf now, we get 2 loaves of bread for sale. So here's another point on the new supply curve. The price is $1, and the quantity that the baker is willing and able to sell is 2 loaves. Another point is 3 loaves offered for sale at a price of $1.50 per loaf. So here's a point on the new supply curve. We get 3.5 loaves offered for sale at a price of $2.10 per loaf. So here's another point. Price $2.10, quantity 3.5 loaves. We get 4 loaves for this particular baker when the price is up to $2.50 per week. So that's going to be this point, 4 loaves, $2.50. We get 5 loaves at a price of $3 per loaf. That's going to be this point in the diagram. And 6 loaves at a price of $4 per loaf. That will be this point in the diagram. And finally, we get 6.5 loaves at a price of $5 per loaf. So that's going to be this point up here on the diagram. $5 on the vertical axis and 6.5 loaves on the horizontal axis. I'm trying to be careful here, make sure that my numbers line up. 5 and 6.5. Now I can connect these dots because all the prices and quantities in between are imaginable, and I'll label my new curve S prime. It's a new relationship between price and quantity for this baker after the price of inputs increases. So the supply curve has shifted inwards. The increase in the price of inputs made bread a less profitable business and resulted in our supplier offering a smaller quantity of bread for sale at every price. Now, let's go back and review something that we talked about when we introduced the concept of shifts back in our study of the demand curve. If the price of bread changes, you move along your given supply curve. A change in the price of bread leads to a change in the quantity of bread supplied, and that's represented as a movement along a given supply curve. But if you change one of those variables that we hold constant when we draw the supply curve, then you have to shift the supply curve. The entire relationship between price and quantity changes for that baker because input prices have increased. We call this change in one of those variables, and the shift in the supply curve, a change in supply. A change in quantity supplied is a response to the price of bread changing, and that's a movement along the supply curve. But if you change one of those other factors, like the price of inputs, technology, and so forth, then you have to redraw the entire supply curve, and we call that a change in supply. In the next lesson, we'll go through an entire catalog of factors that can shift the supply curve. We will look at all of those things that can cause a change in supply. And I'll give you a chance to make some predictions about which way you think the supply curve will move in each case. In this lesson, we will show how the determinants of supply show up in the supply curve diagram. Let's start with a list of the factors that influence the amount of bread that the baker will offer for sale. They include expectations about future prices, technology, the price of inputs, and finally the price of bread itself. Let's start here with the price of bread. How does a change in the price of bread show up in this diagram? The answer is, a change in the price of bread leads to a movement along the supply curve, a change in the quantity supplied. When the price of bread increases, the baker is able to cover the rising opportunity costs associated with expanding his output. Therefore, an increase in the price of bread leads to an increase in the quantity of bread supplied. We call this movement along the supply curve in response to a change in the price of bread, a change in quantity supplied. When the price of bread increases, we move up the supply curve. The quantity increases. When the price of bread falls, we move down the supply curve. The quantity supplied decreases. Let's now look at another factor. And this is a factor that we usually hold constant when we draw the supply curve. That is, the price of inputs. What happens to the supply curve if the price of inputs, like milk and eggs, increases? What happens to the relationship between price and quantity? You answer. What happens to the supply curve when the price of inputs increases? The answer is, with higher input prices, the profitability of bread decreases. That is, the baker can make less profit by baking bread. So, the quantity supplied reduces or is reduced at every price. There is a smaller quantity of bread supplied at every price when the price of inputs increases. We call this a decrease in the supply of bread. What would happen, on the other hand, if the price of inputs were to decrease? Let's suppose that bread or that milk and eggs go on sale and the baker is able to buy them at a lower price. In that case, what would happen to the supply curve for bread? The answer is, with lower input prices, the supply of bread increases. That is, a larger quantity of bread is supplied at every price. Again, we have a change in supply because we've changed one of the variables that we hold constant when we draw the supply curve. An increase in input prices leads to a decrease in supply. A decrease in input prices leads to an increase in supply. Let's consider another factor that influences the supply of bread. This time we'll consider technology. Now, it's hard to talk about technology increasing or decreasing. Instead, we talk about technology improving or worsening. Technology improves, meaning that the firm is now able to make more output with a given amount of input. You can stretch your inputs further. You can use them more productively, thereby increasing the amount of output you get from a given quantity of eggs and milk and flour. If technology improves, what will happen to the supply of bread? You decide. If technology improves, the cost of production will fall. Making bread becomes more profitable, and the supply of bread increases. The supply curve shifts outward, indicating that the baker is now willing and able to offer a larger quantity of bread for sale at every price. There is an increase in supply in response to an improvement in technology. Now, we don't usually talk about a worsening of technology. I mean, that would require that you forget how to do things that you used to know how to do. But sometimes it becomes more difficult to organize your activities or something like that. There may be changes that influence your ability to use a particular technology. If technology should actually worsen due to some other kinds of administrative problems, or perhaps you lose access to a technology that you used to be able to use because you had a license for a particular process or something like that. If technology were to worsen or you were to lose access to a superior technology, what would happen to the supply curve for bread in that case? The answer is, if technology worsens, the cost of production increases. You're not able to do things that used to lower your costs, and therefore the cost of production being higher makes the production of bread less profitable. So bakers will offer less bread for sale at every price. A worsening of technology leads to a decrease in supply, which is an inward shift. an inward shift of the supply curve. Let's now consider one further factor. Suppose the expectation is that bread prices are going to be higher in the future. Maybe bakers believe that the price of bread is going to rise next week. How would that influence the amount of bread that they offer for sale today at any given price? With the expectation of higher future bread prices, bakers will take the bread off the shelves today, put it in the freezer, and wait and sell it next week. That is, the supply of bread will shrink. Bakers will offer less bread for sale than they would if they expected prices to remain constant. Bakers will hold off on producing bread, or they will hold their existing inventory and wait to sell it after the price is increased. So the expectation of future prices being higher leads to a decrease in the supply of bread today. What would happen, on the other hand, if the sellers expect that the price of bread is going to be lower next week? Would that cause an increase or a decrease in supply? The answer is supply would increase. Bakers are trying to sell their bread before the price falls, and that would lead to a larger quantity of bread supplied at every price. The supply increases when the expectation is for lower prices in the future. So there you have it, a catalog of things that can shift the supply curve. We formed this catalog by starting with a list of all of the factors that influence supply. Once we had the list, we considered how each factor in the list would change the seller's behavior. We showed, first of all, that a change in price causes a movement along the supply curve, a change in quantity supplied. Remember the rule, you never shift a curve when you're changing one of the variables that's on the axis. If you're changing price and quantity, you're moving along the curve. However, if we change some of the other factors that are held constant when we draw the curve, we have to redraw the curve, or shift it. In the case of input prices, higher input prices reduce the profits of the baker and lead to a decrease in supply. Lower input prices increase the profitability of making bread and lead to a higher quantity supplied at every price. Another factor that influences supply is technology. If technology improves, the cost of production will be lower. You can get more output from a given amount of inputs. That's going to lead to a larger quantity supplied at every price. We call that an increase in supply. If technology worsens, the supply curve shifts inwards. That is, firms will supply less bread at every price, a decrease in supply. Finally, expectations of higher future prices lead to withholding bread today, a reduction in supply. And expectations of lower future bread prices lead to a big increase in supply today as sellers try to sell their bread before the price falls. So there you have it. Any of the factors that change the behavior of sellers are going to be reflected either as a movement along the supply curve or a shift in the supply curve. If it's a change in price, we move along the curve, a change in quantity supplied. If it's a change in any of the other factors that we usually hold constant, we reflect that by a shift in the supply curve, and we call that a change in supply. Now we'll look at how we move from the individual firm's supply curve to the supply curve for the whole market. In this lesson, we'll move from the individual firm's supply curve to the supply curve for the market. And we'll use the same procedure we used when we derived the market demand curve. We'll be adding up the supply quantities of the individual firms at any given price to find the total market quantity supplied. Let's look first at a particular bakery, and now we'll call this Jim's Bakery. Jim is willing and able to supply 1 loaf of bread per week when the price of bread is 40 cents per loaf. If the price is 60 cents per loaf, Jim is willing and able to supply 2 loaves per week, and so forth. The information in this table represents the quantity of bread that Jim is willing and able to supply at different prices, holding constant the price of inputs technology, and expectations about future prices. Now let's look at the supply behavior of another firm. This is Dan's firm. Dan is willing and able to supply 2 loaves of bread per week when the price of bread is 40 cents per loaf. He's willing and able to supply 3 loaves of bread at a price of 60 cents per loaf, and so forth. As the price of bread increases, the quantity supplied from Dan's bakery increases. Suppose that Dan and Jim have the only bakeries in town. What does the market supply curve for bread look like? The market supply curve for bread will be the sum of the individual supply curves of Dan's firm and Jim's firm. At any given price, to find the market quantity supplied, simply add the quantity supplied by Dan's firm to the quantity supplied by Jim's firm. For instance, at a price of $1.50 per loaf, Dan's firm supplies 5 loaves of bread per week. Jim's firm supplies 4 loaves of bread. The market quantity supplied in that case will be 5 plus 4, or 9 loaves of bread each week. You can do the same for any given price. Find the quantity that Dan's firm is willing and able to sell. Add it to the quantity that Jim's firm is willing and able to sell at the same price, and that gives you the market quantity supplied. Now, we can put Dan and Jim's information together and wind up with the market supply schedule for bread. At any given price, this table tells you the quantity supplied by Dan plus Jim's bakery. The next step in this lecture is to move this information over to the board and represent it in diagrams. Here is the supply curve for Dan's firm. I took the numbers from Dan's table and I put dots in this diagram to represent the price-quantity combinations that describe the relationship for Dan's bakery. At a price of 40 cents per loaf, we get 2 loaves a week from Dan. At a price of 60 cents per loaf, we get 3 loaves, and so forth. Now, we know that these are not the only possible price-quantity combinations. Price and quantity can both vary continuously. So I can connect the dots and get Dan's supply curve for bread. I'll call that S sub D. The same thing with Jim's information. I'll move it from the table into the diagram by plotting the combinations of price and quantity that describe the behavior of Jim's bakery. And if I connect the dots, I get Jim's supply curve for bread. If I want the market supply curve, I have to add together these 2 individual supply curves. And just like I did before, I'll be using horizontal summation. I will pick a particular price, take the quantity that I get from Dan, add it to the quantity that I get from Jim, and that will give me the market quantity supplied at that price. Let's start by choosing the price of 40 cents per loaf. At a price of 40 cents per loaf, we get 2 loaves from Dan and 1 loaf from Jim. Add Dan's 2 loaves to Jim's 1 loaf, and that gives us a total market quantity supplied of 3 loaves at a price of 40 cents per loaf. So I put a dot here in the market supply curve with a quantity of 3 and a price of 40 cents. That's the same thing if I took a ruler and I added 2 loaves from Dan's bakery to 1 loaf from Jim's bakery, and that gave me a total of 3 loaves, and I graphed it right here in this diagram. 3 loaves in the market at a price of 40 cents per loaf. I can do the same for any price on the axis. Let's say a price of 60 cents per loaf. In that case, I get 3 loaves from Dan, add that to 2 loaves from Jim, for a total of 5 loaves supplied when the price is 60 cents per loaf. Keep picking any price you want and add the quantity from Dan's firm to the quantity from Jim's firm to get a total quantity supplied in the market. Alternatively, you can just go back to the table representing quantities supplied, that table that we got when we added Dan's output to Jim's output, and you can graph the numbers directly. At a price of $1 per loaf, we get a quantity supplied of 7. At a price of $1.50 per loaf, we get a quantity supplied of 9. At a price of $2.10 a loaf, we get a total of 11 loaves supplied. At a price of $2.50 per loaf, the quantity supplied is up to 13 loaves per week. There's the market supply curve. I can connect the dots and label this with an S to indicate that this is the supply curve for the whole market. The supply curve is the horizontal summation of the supply curves of the individual firms in the market. To get this curve, pick a price and add the quantity from Dan's bakery to the quantity from Jim's bakery at that price to get the quantity for the market as a whole. Now, what's going to shift the market supply curve? The answer is anything that shifts the individual supply curves will shift the market supply curve. After all, the market supply curve is simply the sum of the individual curves, so anything that moves Dan's curve or Jim's curve will shift the market supply curve as well. And what are those factors? They're all of the factors that we held constant when we originally drew the individual firm's supply curves. The price of inputs, technology, and expectations about future prices. If any of those factors changes, we have to redraw the individual firm's curves, and consequently, we have to shift the market supply curve as well. Now, this wraps up our introduction to the behavior of suppliers and the behavior of buyers. Now we're ready to put the two sides of the market together and find the conditions under which we have a stable situation. In the next lecture, we'll be putting supply and demand together in one diagram to find the equilibrium price and quantity traded. What happens to the price of a good or service when something changes in the market? Can you predict how a change in the environment will influence the price of a good and the quantity traded? Well, you can using the tool that we developed in the last lecture. Here's what a competitive equilibrium looks like. The competitive equilibrium is the price and quantity where supply and demand are equal. That is, it's the price at which the quantity demanded on the red curve is equal to the quantity supplied on the blue curve. Now, anytime we change anything that is held constant when we draw this picture, we have to redraw the picture. That means if we change consumer income, the price of substitute goods, the price of complement goods, expectations, or if we change input prices or technology, we have to shift the curves. And when the curves shift, we have to find a new equilibrium price and quantity. Let's take an example. Suppose we consider a case where in the market for bread there's a change in the price of a substitute good. Let's suppose that bagels become more expensive. If bagels become more expensive, what will happen to the price of bread and the quantity of bread traded? Well, there is a series of steps that you should go through to answer a question like this. And this series of steps will help you anytime you try to solve one of these problems. The first step is identify which side of the market is affected. If the price of bagels goes up, who cares, buyers or sellers? The answer is buyers care because bagels are a substitute for bread for consumers. That's the first thing you need to resolve. Who cares, buyers or sellers? Because that tells you which curve you're going to be shifting. The second question, how will the change affect the curve? So if the price of a substitute good increases, we know we're going to be dealing with the demand curve, but will it shift in or will it shift out? The answer in this case is the curve shifts outwards. When the price of a substitute good increases, the demand for bread increases as well. That is, customers are going to want to buy more bread at every price. So the demand curve for bread shifts outwards. The third question you want to answer is, what happens to the equilibrium? That is, after you shift the curve, which direction will the bidding mechanism take the price of the good? Will it take it up or will it take it down? Let's look at this example carefully. If the price of a substitute good increases, we know that the demand for bread is going to increase. So the demand curve is going to shift outwards in this direction. And we'll have a new demand curve, which we could label D prime. Here it is. And this is the demand curve after the change in the price of bagels. Next thing you want to notice is, at the original price for bread, say $2.10 per loaf, the quantity of bread demanded is now larger than the quantity supplied. The quantity supplied hasn't changed, because at a price of $2.10, we would still be at this particular point on the blue curve, still with, say, 5 loaves of bread supplied each week. However, with the increase in the price of bagels, the quantity demanded has increased to a new point over here on this new red curve. The old red curve doesn't apply anymore because of a change in the environment. With an increase in the price of the substitute good, the quantity demanded is now over here on this new red curve, even though the supply is still over here on the old blue curve. We've now got a gap between quantity demanded and quantity supplied at the original price of $2.10. Well, you know what's going to happen next. We have an excess demand for bread, and that's going to cause the bidding mechanism to kick in. The price of bread is going to be bid up. And as the price of bread is bid up, some buyers will leave the market and new sellers will enter the market. As the quantity demanded shrinks with the rising price and the quantity supplied increases, we will approach a new competitive equilibrium. We will approach a new equilibrium with a higher price and a larger quantity of bread traded. Let me go ahead and draw this curve in and show you this adjustment process very carefully. We have a new demand curve. The new demand curve results from the increase in the price of a substitute good. With consumers wanting to buy a larger quantity of bread at every price, the demand curve is now shifted out here. Well, that gives us a problem, because at the original price, the quantity supplied, the point on the blue curve, is now less than the quantity demanded over here on the new red curve. So the distance between these 2 points is an excess demand at the original price. That causes the bidding mechanism to kick in. And as the price rises, buyers begin to buy less bread than they were buying before. We have a movement along our new demand curve. We have a decrease in quantity demanded as the price is bid up. Over here on the supply curve, the rising price leads new suppliers to enter the market, or existing suppliers to increase the quantity they supply. As the price rises, suppliers can cover rising opportunity costs associated with providing more bread to the market. Eventually, we reach this point at which the quantity demanded and quantity supplied are equal with the new demand curve and the original supply curve. This new price and new quantity are our new competitive equilibrium. So if I draw a dashed line over to the price axis, I could call this P star prime, the new higher price. And if I draw a dashed line down to the quantity axis, I could label this Q star prime, an increase in the quantity traded. So the market for bread has gotten a little bit bigger because bagels, a substitute, are now less attractive. More consumers buying more bread at every price leads to an increase in the price of bread and an increase in the quantity of bread traded. We got rid of our excess demand through the bidding mechanism, which pushed up the price. And as buyers and sellers adjusted to the new higher price, the quantity traded changed. This is just one example of how a change in the environment will shift one of the curves and create a new competitive equilibrium. In the next lesson, we'll look at a whole catalog of factors that can shift the demand curve or shift the supply curve, thereby changing the competitive equilibrium price and quantity traded. In this lesson, we present a catalog of comparative statics. Comparative statics are thought experiments where you change something and see what happens. We call them statics because it refers to comparing one state with another state, the state before the change with the state after the change. In our last lesson, we did an example of comparative statics. We looked at what happens to a competitive equilibrium when we changed the price of a substitute good. We saw that the demand curve shifted and the price and quantity traded at competitive equilibrium changed. Well, that was only one example. Now we're going to present all the examples that I can think of. The thing to remember is there are a limited number of comparative statics that you can do in a supply and demand diagram. That's because there are only two curves you can shift and only two directions to shift each curve. So a complete catalog of comparative statics would look like the following. We would have one case where the demand curve shifts outwards, one case where the demand curve shifts inwards, one case where the supply curve shifts outwards, and one case where the supply curve shifts inwards. Each of those cases is going to lead to a different combination in changes of price and quantity. And each of those cases will correspond to a different set of stories about the real world. So what I'll do in this lesson is go through each of those cases one at a time until I've done all four. Let's start with case number one, the case we considered in the last lesson. Here's the case where the demand curve shifts outwards. If the demand curve shifts outwards, then if you hold the price steady at the original level, you will have an excess demand. The new quantity demanded will be larger than the old quantity demanded. The quantity supplied will be the same as before at that original price, and you've got excess demand or a shortage. The bidding mechanism will push up the price of the good. Some buyers will drop out, and some new sellers will enter the market. The end result when the demand curve shifts outwards is the equilibrium price rises, and the equilibrium quantity traded increases. Now, what are the stories that could cause that to happen? The first story would be an increase in the price of a substitute good. When the price of a substitute good increases, the demand for bread itself will increase as consumers consume bread instead of bagels. The second case that would shift outwards the demand curve would be a decrease in the price of a complementary good. If the price of cheese falls, people want more bread and cheese sandwiches, so the demand for bread increases, pushing up the price and increasing the quantity traded in equilibrium. The third case would be if there were a change in consumer income, and here we have two possibilities. If bread is a normal good, then an increase in income will lead to an increase in demand for bread, and the higher price and larger quantity in equilibrium. If bread is an inferior good, on the other hand, then a decrease in consumer income would cause the demand curve to shift outward. If this were beans instead of bread, and beans were an inferior good, then lower consumer income would lead people to buy more beans at every price, and that would lead to a new higher price in equilibrium and a larger quantity of beans traded. Another thing that would shift outward the demand curve would be expectations changing. If people expect the price of bread to be higher in the future, they're going to buy more bread today. And quite ironically, that would push up the price of bread. It becomes a self-fulfilling prophecy. If people are hoarding bread today for fear of higher prices in the future, their actions have the result of fulfilling the prophecy. The price of bread indeed rises. Finally, since this is the market demand curve for bread, an increase in the number of buyers in the market will shift the demand curve outwards. If the number of consumers grows in this market, or more people decide they like bread and enter the market for bread, that will push up the price and increase the quantity traded. So that's case one, an outward shift in the demand curve. And we looked at what happens and the stories that could lead to it. Let's consider now case number two. Case number two is the case of an inward shift in the demand curve. If the demand curve shifts inwards, then at the original price, we have now an excess supply of bread. With the demand curve shifting inward, consumers want less bread at every price. So at the old price, the quantity of bread demanded is less than the quantity of bread supplied, the point on the blue curve. This causes the bidding mechanism to kick in, sellers put their bread on sale, and the price of bread falls. As the price of bread falls, some buyers come back into the market for bread, and some sellers drop out of the market. The bidding mechanism comes to rest when the quantity demanded is equal to the quantity supplied at the new equilibrium price. The new equilibrium price will be lower. It had to fall to get rid of that excess supply. And the quantity of bread traded will shrink. Since people want less bread now, the quantity of bread actually traded in the market will be smaller. Let's look at the stories that could result in an inward shift in the demand curve. The first thing would be if the price of substitute goods falls. If bagels become less expensive, then people will buy less bread and more bagels instead. If the price of a complementary good increases, like cheese, if cheese gets more expensive, people want fewer cheese sandwiches, and that means they will buy less bread at every price. The demand curve shifts inwards because of the higher price for a complement. The third case would be a change in income, and once again we have two cases. If bread is an inferior good, then the demand curve shifts inwards when income increases. Consumers want less bread because now they're better off and they buy other things instead. But if bread is a normal good, then the inward shift corresponds to a decrease in income. When your income falls, you buy less bread at every price. Another thing that would shift inward the demand curve would be the expectation that the price of bread will fall. People delay their purchases of bread, and the demand for bread shifts inwards. It's reduced. However, you can see that the expectation that future prices will be lower turns out to be a self-fulfilling prophecy. By reducing their demand for bread, people lead to a lowering of the price. The bidding mechanism kicks in, lowers the price of bread, and the expectation becomes self-fulfilling. Finally, the last thing would be if there are fewer traders in this market. With fewer traders in the market, the demand will be less, and therefore the equilibrium price will fall. All of these are the same factors that shift the demand curve outwards, only now we're considering the opposite cases. So there's case 2, an inward shift in the demand curve. This will occur anytime something causes consumers to want to buy less bread at every price. And the result is a lower equilibrium price and a smaller quantity traded in equilibrium. Let's look now at case number 3, an inward shift in the supply curve. Now we have a different set of factors that leads to an inward shift in the supply curve, because we're no longer talking about the behavior of consumers. Now we're talking about the behavior of sellers. In this case, when the supply curve shifts inwards, the immediate result is that we have an excess demand for the product. That is, at the original price, the original equilibrium, where the original demand curve and the original supply curve cross, we have P star as our equilibrium price and Q star as our equilibrium quantity. If we keep the price constant and the supply curve shifts inwards, that is, if we have a decrease in supply, we're now going to have a small quantity supplied and a larger quantity demanded. So we have an excess demand for the product, given the new quantity supplied and the original quantity demanded. Well, this is going to cause the bidding mechanism to kick in, and as usual, the bidding mechanism deals with an excess demand by causing the price to rise. The price is bid up. And as the price is bid up, some buyers leave the market, and some of those sellers who thought they were going to leave the market come back in because the rising price makes it worth their while to continue to offer bread for sale. The result is that the price of the good rises in equilibrium. The new equilibrium price is higher, and the equilibrium quantity traded is smaller. This will be the case anytime the supply curve shifts inwards, anytime there is a decrease in supply. Well, what are the factors that lead to a decrease in supply? The first would be an increase in the price of inputs. If milk, eggs, or flour become more expensive, then our baker finds it less profitable to make bread, and bakers will bake less bread and sell less bread at every price. A second factor would be a change in technology. If technology worsens or our baker loses access to a low-cost technology, then the cost of production will increase. It's less profitable to make bread, and the quantity of bread offered for sale will be lower at every price. Finally, there could be a decrease in the number of sellers in this market for any number of reasons. Remember, this is the market supply curve, and the market supply curve is the sum of the supply curves of the individual sellers. If we have fewer sellers in the market, the curve will shift inwards because fewer curves are being added together. Any of these factors will lead to an inward shift in the supply curve, and with that inward shift comes a higher equilibrium price and a smaller quantity traded. That's case number 3. Let's go now to the final case, and that is an outward shift in the supply curve. The outward shift in the supply curve occurs if sellers are offering more bread for sale at every price than they were before. Originally, the equilibrium price was P star, and the equilibrium quantity was Q star. However, something occurs that causes sellers to want to sell more bread at every price. At the original price, therefore, we now have excess supply of bread. The quantity supplied is greater than the quantity demanded at the original price. The bidding mechanism, once again, takes over and leads sellers to cut the price of their bread. To make sure they can sell their product, they lower the price. And as the price falls, some sellers decide that they're going to drop out of the market. They can no longer cover their opportunity costs. Meanwhile, the falling price draws some buyers into the market. These buyers are now willing and able to purchase more bread than they were buying before. The result is a new equilibrium price that's lower than the original. The equilibrium price falls in this market, and the equilibrium quantity traded increases. What are the real-world events that could lead to this outcome? The first would be if the price of input goods falls, making the production of bread more profitable. Sellers would make and sell more bread at every price than before. The second possibility would be an improvement in technology. With an improvement in technology, once again, production costs will fall, making it more attractive to offer bread for sale. Producers respond by offering more bread for sale at every price, an outward shift in the supply curve. And finally, if the number of sellers in this market increases, since it is the market supply curve, the supply curve shifts outwards. All of these factors shift the supply curve outwards, leading to a lower equilibrium price and a larger equilibrium quantity traded. So we have 4 cases, and each of these cases results in a different combination of changes of price and quantity. If the demand curve shifts outwards, the price increases, as does the quantity traded. If the demand curve shifts inwards, we have a decrease in the price as well as a decrease in the quantity traded. If the supply curve shifts outwards, the price will fall, but the quantity traded will increase. And if the supply curve shifts inwards, then the price will increase and the quantity traded will fall. Those are all the possibilities we have for comparative statics. So now that you've got the catalog, you're ready to try some experiments of your own. In this lecture, we put together our previous analysis about supply and demand to come up with a model of the market. And the payoff is we have a way of predicting how factors in the environment will influence the price of a good and the quantity of that good traded. We're going to be developing a tool that economists use called the competitive equilibrium. The competitive equilibrium is what happens when you get together a bunch of buyers and sellers, all of whom believe that they have no influence over the price. That is, all of the agents in our market are price takers. They accept the market price as given and do the best they can subject to that price as a constraint. So the buyers take the price as given and choose their quantity demanded. The sellers take the prices given and choose their quantity supplied. When the price is such that the quantity supplied is equal to the quantity demanded, we say that we have a competitive equilibrium. Now, first we should define the concept of equilibrium in economics. An equilibrium is a situation from which there is no tendency to change. And as we will see in our model of supply and demand, there is only one price at which there is no pressure for something to change. Let's go back to the analysis that we've developed earlier. The red dots in this diagram represent quantities demanded at different prices. This information comes from the table that's over on the board. At a price of $5, the quantity demanded is 1 loaf of bread per week. At a price of $4 per loaf, the quantity demanded is 2 loaves per week, and so forth, giving us this collection of red dots. We could connect these red dots and form the demand curve, but we're going to wait to do that for just a moment, because I think that leaving this in the form of dots will help me make my argument more clearly. The blue dots represent the supply curve. That is, at a price of 40 cents per loaf, we get 1 loaf of bread supplied per week. 2 loaves at 60 cents, 3 loaves at $1, and so forth. The blue dots represent the supply curve. Now, we've got these price-taking buyers and price-taking sellers. All of them are doing the best they can, subject to the price that they are given by the market. Let's find now the price at which an equilibrium obtains. Suppose, first of all, that we consider a price of $1 a loaf for bread. What would happen in that case? Well, with a price of $1 per loaf for bread, there are 3 loaves that bakers are willing and able to supply each week. The quantity supplied is 3 at a price of $1. At a price of $1, the quantity demanded, however, is 8 loaves per week. That is, buyers are willing and able to purchase 8 loaves of bread at a price of $1. The fact that there are more buyers than sellers, or the quantity demanded is greater than the quantity supplied at a price of $1, means that we have excess demand. We have excess demand, which is the difference between the quantity demanded and the quantity supplied at the price of $1. I'll label this with a little sign that says excess demand. Now, when there is excess demand, the bidding mechanism takes over. The bidding mechanism is the process by which unsatisfied buyers try to bid up the price of bread to guarantee that they get some. After all, we've got 8 loaves of bread demanded here and only 3 loaves of bread supplied. We've got 5 loaves of bread excess demand. That could be 5 people who aren't able to buy their loaf of bread at a price of $1 per loaf. Those 5 people are now going to offer sellers a higher price. They're going to bid the price of bread up to $1.10 or $1.20 or $1.50 or $2 a loaf. They'll continue bidding until either it's no longer worth it to bid higher prices or until enough bread becomes available that the shortage of bread is eliminated. Look, if the price of bread goes up to $1.50 per loaf, the quantity supplied increases to 4 loaves. Some baker has a reservation price of $1.50. That is, he offers his loaf of bread for sale as soon as the price goes up to $1.50. At the same time, when the price goes up to $1.50, we've had one of the buyers drop out. That is, there was one buyer who was willing to pay $1, but not $1.50. So the excess demand shrinks as the price rises because additional sellers enter the market and some of the buyers drop out of the market. Finally, when the price of bread rises all the way up to $2.10 a loaf, the quantity supplied is equal to the quantity demanded. Enough buyers have left the market and enough sellers have entered the market to give us an equality of quantity demanded and quantity supplied. At a price of $2.10 per loaf, the quantity demanded equals 5 loaves of bread per week, and the quantity supplied equals 5 loaves of bread per week. This means that we have a competitive equilibrium. Taking prices as given, the quantity demanded by buyers and the quantity supplied by sellers are equal at a price of $2.10 per week. And we get there by the bidding mechanism. Buyers who can't get bread at the lower price will bid up the price. And as buyers and sellers respond to the rising price, an equilibrium is established. The excess demand is eliminated as the quantity demanded falls and the quantity supplied increases with the rising price. Now, you can see the same analysis working from the other direction. Suppose we start with a high price for bread. Suppose $4 a loaf. What would happen in that case? At a price of $4 per loaf, the quantity demanded is going to be smaller, that is 2 loaves of bread per week. Because the price of bread is high, the quantity demanded will be much smaller. However, bakers are very excited about this high price, and the quantity supplied is quite high because a lot of bakers can cover their opportunity cost at that higher price, and there's a larger quantity supplied at $4 per loaf. That quantity in our example is 8 loaves of bread per week. Well, there you've got a problem because we've got an excess supply. That is, the quantity supplied is 8 loaves at $4 per loaf, and the quantity demanded is 2 loaves at $4 per loaf. We have an excess supply of 6 loaves of bread every week. Bread piles up unpurchased on the shelves. What's going to happen in that case? The bidding mechanism will operate from the other direction. In this case, sellers who are unable to move bread from their shelves will begin to put the bread on sale. They will lower their price. Some sellers will offer their bread for $3.50 a loaf, or $3, or $2.75, and the price will begin to fall. As competition through the bidding mechanism pushes down the price of bread, two things happen. First, additional buyers will enter the market. Notice when the price drops to $3 a loaf, we can sell 3 loaves of bread because 3 people are willing and able to purchase bread at that price. As the price drops down to $2.50 a loaf, the quantity demanded increases to 4 loaves of bread, and so forth. So additional buyers enter the market as the price falls. As the price falls from the supplier's perspective, things are getting less attractive. So at a price of $3 per loaf, we find that a seller or two may have left the market. The quantity supplied is down to 7 loaves of bread. And at a price of $2.50 per loaf, the quantity supplied drops even further to 6 loaves of bread. Finally, when the price is $2.10 per loaf, the quantity demanded is equal to the quantity supplied, and the excess supply has been eliminated, partly by bringing additional buyers into the market, and partly by reducing some of the oversupply by pushing some of the sellers out of the market, sellers who can't cover their opportunity costs as the price of bread falls. Well, what's the outcome? The outcome is we wind up with a stable situation. The price of bread is set at $2.10 per loaf. We call that the equilibrium price. Since the quantity supplied and the quantity demanded are equal, and they are both equal to 5 loaves at that price of $2.10, the bidding mechanism is going to just sit there and do nothing. There's no tendency for prices to change. There's no excess demand, so prices don't rise. There's no excess supply, so prices won't fall. When quantity supplied and quantity demanded are equal, we're in a stable situation, a competitive equilibrium. So when the price is $2.10, the quantity of bread traded will be equal to 5 loaves of bread per week. We can label this P star, $2.10. That's the price at which supply and demand are equal. And we can label this Q star, the quantity of bread that's traded at a price of $2.10. So there you have it, the stable outcome, the competitive equilibrium. The bidding mechanism takes us to the point where the quantity supplied and the quantity demanded are equal. And once we reach that point, there is no further tendency to change. In the next lecture, we'll look at factors that can shift the supply and demand curve, upset this equilibrium, and lead to a new equilibrium. But first, let's connect the dots and make this picture look like something that we might be more familiar with. Connect these dots, and they become the demand curve. Connect the blue dots, that is, allowing prices and quantities to vary continuously, and you get a supply curve. The competitive equilibrium is found at the place where the supply curve and the demand curve intersect. As in most economic graphs, the most interesting point is where the curves cross. And it's where the curves cross that we find the price and quantity where supply and demand are equal. And when quantity supplied and quantity demanded are equal at a particular price, there is no further tendency to change. This is what a competitive equilibrium looks like. And usually we will mark the price and quantity with lines down to the axis to show us the price and quantity at which the market has a stable outcome.